Hi everyone, so we're going to do a few examples on inclined planes. So this is where rather than the motion happening vertically or horizontally, it's going to be at some angle to the horizontal or to the vertical. Okay, so example 1. A particle of mass 5 kilograms slides down a smooth plane, and the first thing in this question that's really important, and this will become more important over the next few lessons when we do some work on friction, but if we're told that this plane is smooth, it means that there's no frictional force holding back the motion of this particle. So a particle of mass 5 kilograms slides down a smooth plane inclined at 45 degrees to the horizontal. So we'll draw a diagram, and then we're asked to find the acceleration and the normal reaction between the particle and the plane. And this question, so we need to make sure we're answering it the way the examiner asks, tells us to leave our answers in terms of G, so no need to substitute in 9.8 for G in this question. First of all, then, let's draw a diagram. So we've got a plane inclined at 45 degrees. Doesn't need to be to scale or anything like that. So 45 degrees here. And we've got a particle of mass 5 kilograms. So let's get that on our diagram. So our weight down is 5g. So that's the only forces at the moment that we're told in the question, but let's add our reaction force, so that's really important. And the reaction force is always perpendicular to the plane that we're in contact with. So this reaction force between this particle and this plane is perpendicular to the surface. So it's going to go like that. I'm going to call that R for reaction. Okay. And the other thing I'm going to put on my diagram is which direction this is going in, just so that when I'm taking positive, I'm going to take the direction of motion as positive. So this is sliding down the plane, so I'm going to put my acceleration on there just to remind me that acceleration is down the plane that way. Okay. Now, when we're looking at this, the motion is in this plane here. It's moving down the plane here. So what I want to do is look at forces that are either parallel to this plane of motion or perpendicular to the line of motion. So we're going to look at forces acting in this direction and then forces acting in this direction. So parallel and perpendicular to the slope here. And to do that, I'm going to need to resolve this force, this weight, 5g, into its perpendicular component. So I'm going to have that perpendicular component acting in that direction and this perpendicular component acting in the other direction. And again, the resultant of these two acting together, we've seen this before, is going to give us this sort of hypotenuse, if you like, of force here. This resultant force here is equivalent to these two green components acting together. Okay. Now, if this is 45 degrees, this is 45 degrees as well. It doesn't look like it because I haven't drawn it to scale, because this is a right angle triangle, so this is 90. And what I'm going to do, and what I'm going to get into the habit of doing, is actually putting this angle on. Just because if this was theta, or something that wasn't as nice as 45 degrees, then we would be able to work out this one. But if we were given this as an unknown, theta, this would be 90 minus theta, and it's just a bit more difficult to work with. So I'm always going to be looking at this angle here. And in this question, that's going to be 45 degrees. Okay, so there's my 45 degrees. So then 5g, this component adjacent to this force, 5g cos theta, this component, which is equivalent to this vector force here, so this one is 5g sine 45. I'm just going to change that theta to a 45 because I know what my angle is there. I apologise if it's a little bit noisy outside. I think one of our neighbours is mowing the lawn. Okay, let's have a look at this then. So now we're going to look at forces acting parallel to the plane and then forces acting perpendicular to the plane. Okay, so parallel to the plane. And I'm telling the examiner which way I'm going to take as positive. So parallel to the plane in this line of motion, I'm going to take down the plane as positive here because that's the way that the resultant force, the resultant motion is happening. So I'm going to take down the plane as positive. So I'm just telling the examiner that, and it's a reminder to me as well, so they can see which way is positive here. Okay, so that means down the plane in that direction, the resultant force is going to be this 5g sine 45, which is acting down the plane. And there's nothing holding this back because this is a smooth plane. Okay, if this was a rough plane, we'd have to put friction holding this thing back, and then we'd have minus the friction here. And we're going to do some work on that, as I say, over the next few lessons. But for today, we're just going to look at this smooth plane situation. So that's my resultant force. So that's going to give me, if I do sine 45, that's going to give me 5 root 2 g over 2, because sine 45 is root 2 over 2. Okay. So there's my resultant force, and we know that resultant force is equal to ma. So mass here is 5, so 5a, 5 root 2 g over 2. So my acceleration is root 2 over 2 g meters per second squared. The question wants me to leave it in terms of g, so I'm going to leave it like that. If it didn't say this, I'd just bang this in my calculator, get my answer, and then round it to 3SF. So there's that part of the question done. And the other part of the question now wants the reaction between the particle and the plane. So it wants this reaction force R. So this time now, I'm going to look perpendicular. I'm going to look at forces perpendicular to the plane. Okay? And here now, it doesn't matter which way I'm going to take as positive, because there is actually no motion perpendicular to this plane. The only thing that happens is that this slides down the smooth plane. So there's nothing happening this way. So our resultant force is going to be 0 here. Okay, so let's just make a decision. I'm going to take up away from the plane, perpendicular to the plane in the upwards direction as positive. So that's going to give me my resultant force is equal to R in the positive direction minus 5g cos 45 in the negative direction. Resultant force here is 0 because there's nothing happening perpendicular to the plane. There's no motion this way. And then rearranging that, if I rearrange that, sort this out, I'm going to get R is equal to 5 root 2 over 2 g newtons. And there's my answer to that question. So that's our first example done. I'm going to stop the video now so you can get that into your notes, and then we'll have a look at another couple of examples in the next video.